All right, section 07, congruent and similar figures. Have you heard these words before? Congruent and similar. Do you know what the difference is?
Similar means
Similar kind of means same,
But not necessarily.
but not
Same but not
completely
same.
the same. Same but not the same. Do you know what congruent means?
They're the same shape and same.
Yeah, so congruent is same shape and same size. That is the big key for congruent. Same shape, same size, okay? So kind of like these two shapes that we have going on here, these two triangles right here, I have turned one of them to be facing the other direction, but they are still the same shape and same size. Regardless of their orientation, like how they're facing, they are the same shape, same size, so they are congruent figures. We're going to talk more about those here in a second, okay? The difference between congruent and similar is that similar is, anybody want to take a guess? Yeah, this is same shape, but different size, right? Same shape, different size. That's the only difference. Same shape, different size, okay? So congruent versus similar. Same shape, same size versus same shape, different size. So this would be like similar figures. They're exactly the same shape, but they're different sizes, okay? All right, let's talk more about congruent. So when they talk about congruent, this is more of like the geometry section of like the review chapter 0, right? Like this kind of has to do with geometry, so this is kind of review on geometry. Tomorrow, we're doing another geometry thing. It's the Pythagorean theorem. Do you guys know what that is? Yeah. Okay, so tomorrow will be a really nice day too because Pythagorean theorem is not terribly difficult. But these next two sections are going to be kind of geometry, okay? So this one is talking geometry, it's talking shapes, and these two triangles are congruent. And they have some labels on here that are really important to know. And they have to do with like these little, we call them in geometry, we call them tick marks. It's a little tick, right? A tick mark. And this says that side BC, that's what that side is, right? B to C, side BC is going to be the same length as what side? DF on the other side because it has one tick mark. So that means that if side BC is, let's say, 13 units, side DF is also going to be 13 units. Does that make sense? Okay. Now the next one, the one that has two tick marks, is AB. From A to B, he will be the same length as from E to F, right? So let's say if that is like 9 units, this is also going to be 9 units. I'm just making these numbers up. I'm just saying that if one is 9, the other one is going to be 9 as well, right? Does that make sense? Okay, now the bottom side, AC is what this bottom side is, from A to C. That is going to be the same length as DE, okay? So let's say that this one is 12, I don't know. That one also has to be 12. Does that make sense? Yeah? Clear as mud? Okay. Then let's talk about the angles. Oh, wait. So let's go over here. They have congruent sides. They have AB, and they named it AB with a length over top of it, and EF, and then they have this symbol in the middle right here. And this symbol, I'll blow it up for you, is an equal sign with a little squiggle over top of it, which is called a? Approximately is 2 squiggles. Right? Isn't approximately 2 squiggles?
Oh, yeah.
Do you know what this is called?
No,
Did you talk about it in Spanish today?
Oh, we did.
The
Oh, wait a
eyebrow.
minute.
Yeah.
Starts for the T.
Ranosaurus Rex.
Nice try though.
Good job, Brandon.
Are you ready for me to give it to you?
Yeah.
Yeah.
It's called a tilde
Yeah.
or a tilde. Maybe sometimes they
I
pronounce
don't
it
know
differently.
what we said.
But it's a tilde. So it's an equal sign with a little squiggle over top of it, and this means congruent. This is the symbol that you use for congruent. So that symbol means AB is congruent or the same size as EF. BC is congruent to FD. These two are congruent, same size. AC is congruent to ED. They're the same size. So that is just the notation that they use for it being congruent. Make sense? Okay, let's talk about angles. So over here, just kind of like how you would anticipate, angle A has 2 tick marks. He is going to match up with angle E. Yeah? Let's say angle A is 80 degrees. Okay, that means angle E is also going to be 80 degrees, right? Okay. B, we'll pick on that one. He has 1 tick mark. He's going to be the same as F. Let's say that that one is, I don't know, let's go 70 degrees. And let's say this one is 70 degrees as well, right? They have to be the same, okay? And then angle C is the last one. He's going to match up with D. But do you know how big his measure is going to be? Got any ideas? How many degrees fit inside of a triangle? 180 always, right? Always 180 degrees. So if this one is 80 and this one is 70, what's this one have to be?
Yeah.
30. In order for it to add up to be 180, that has to be 30 degrees, which means that D is also 30 degrees and they match up, right? Okay, so congruent means exactly the same. And we have over here, they talk about congruent angles. Angle A, that's how they represent angle A, is congruent to angle E. That's how you would like say that. Angle B is congruent to angle F. And angle C is congruent to angle D. Make sense? They're the same size, right? Okay? All right, now the last thing that we're going to talk about is this little thing right here, which is something called a, write this down, congruence statement. A congruence statement, okay? And what this congruence statement says is that, if I read it like in order, this says triangle, and we literally put a triangle as the symbol in front of that. Triangle A, B, C, we're naming that triangle, is congruent to triangle E, F, D. That's what it says, right? Okay, now this congruence statement has a lot of information embedded into it that you don't realize because the order that I put the letters in makes a huge difference. So here's how this works. They are listing A as the first letter here. They're listing E as the first letter here. A and E match up with each other, right? Don't they? A matches up with E, so they put those as the first letters. B matches up with F, because those are the second letters that we have. So B matches F. Yep, that's true. C matches D. Yep, that's true. So the order in which they put them in tells which one matches with which other one. Does that make sense? Okay. Now, when you write out a congruent statement, it doesn't matter the order that you put the first one in. So let me give you an example. Let's say instead of calling it triangle ABC, I call it triangle BAC. I don't know why I would do that because ABC just kind of seems to flow. But let's say I mess it up and I call it triangle BAC. That's fine. I can do that. But the second one has to match that then. I would say is congruent to triangle. What order would the second one have to go in? FED, right? F has to go with B, E has to go with A, and D has to go with C, right? So if I do that and I put the first one in a different order, this one just has to match that order. Does that make sense? So it doesn't matter. These two are fine. Either one will work, just as long as the second one matches the first one. Good? Easy as pretty easy. Okay? All right, here we go. Let's go to example 1. And we have these two triangles, and these two triangles are touching. They're sharing this point C in the middle, which is fine. They're saying that those two guys are congruent, okay? And it says that we want to write a congruence statement, okay? So we're going to start with triangle whatever is congruent to triangle whatever, right? And we just have to name them. That's it. Okay, so let's start with the left one. How would you like to name the left one? ABC. You want to go in order? Sure, that's fine. ABC. Now, if we go with ABC, A is the first letter. What has to be the first letter in the next one? D, because A and D go together. They both have 3 tick marks, okay? B has to go with E, and C goes with C, right? That is my congruent statement done. Make sense? Not too bad, right? We're just putting everything in order the way that it goes, okay? That is a congruence statement. Done talking about congruent. Okay, now we have similar figures, which we said was the same shape, but a different size, right? Not same size, okay? Same shape, different size. Here's how this works, all right? So we have one object that is bigger than the other object. The one on the left is bigger, and this side right here is 4, and let's look at this one, which is 2, right? 4 is corresponding to the side 2, right? So what have we done to get from here to here? We've divided by 2, right? Okay, now, if we're dividing by 2 here, we have to also be dividing by 2 here. Are we? Yes. And we have to also be dividing by 2 for the next one, right? So if instead, like let's say this one was actually a 5, were we dividing by 2 here?
No.
So these figures would not be similar figures. Does that make sense? The sides would not be the same dimension. So here's how you can check this. if I go over to my little diagram over here, they say that they have to be the same proportion, right? So AB is the side that they have on top. How long is AB? 4, right? So 4, which is here, over DE. What's DE? 2. 4 over 2, right? Has to be equal to, what's BC? 6 over EF, which is 3. Equal to, what's AC? 8 over DF, which is 4, okay? 4 over 2, that reduces to 2. 6 over 3 also reduces to 2. 8 over 4 also reduces to 2. So those sides have the same proportion. So they're good to go, okay? Yeah? All right. Now, the next thing we need to look at is the angles. Okay, so here's the deal. I'm going to put some dimensions to these angles, and let's look and see what we've got. So let's say angle A is 60 degrees. Let's say angle B is 100 degrees, and angle C is 20 degrees. Okay? All right, you ready for this? Those are my angles. I'm just making those numbers up. They kind of look approximately that much, so we're just going to go with it, okay? Now, we know that this triangle, the sides are half what these ones were, right? So let's think about that in terms of the angles. If that's the case for the angles, then this angle would be 30 degrees. Let me make it a better color here. This angle would be 30 degrees. This angle would be 50 degrees, and this angle would be 10 degrees, right? If we split them in half. But wait a second. A triangle has to add up to be 180 degrees on the inside. And that one would only add up to be 90 now. So how does that work?
It's not changing.
It does not change, right? Like if I look at this angle here, just look at that angle. This has the same like degree opening, right? Like those look like they're opening about the same amount, right? So that's not 30, that stays 60 degrees, right? The angles don't change. This is still 60, this is still 100, and this is still 20. Otherwise, it doesn't add up to be 180 anymore, right? So if we have similar figures, the angles are still going to be congruent. Even though the figures are similar, the angles are still congruent, right? So angle B is congruent to angle E, etc., right? Is this like not too bad? Okay? Do you see why that is? Only the sides change and not the angles as well, okay? We have this guy down here, which is not called a congruence statement anymore. It is called a similarity statement, okay? So when they ask for that, that's a similarity statement. The only thing that changes in the middle is the symbol. We get rid of the equal sign, and we only put the little squiggle, which is called a tilde, I think. However you pronounce it, whatever. Okay, happy with that? Not too bad? That's similar. So we're saying that they're the same shape but different size, yeah? Okay, now, example 2, we got 2 left. Example 2, determine whether the polygons are similar or not and justify your answer. Okay, so here's how we can check the sides. The only 2 measurements for sides I have is 4 and 8 and 3 and 6, right? The other ones are like the same, you know, the other 2 sides are the same, okay? So what I can do is I can say, I can set up a proportion is what it's called, okay? So I do something over something equals something over something. And you can set up your proportions different ways. How would you like to do it? What over what would you like to do with those numbers? 6 over 8, 3 over 4. Okay, so he's going from right to left and right to left. That will work. We can go 6 over 8 and 3 over 4, okay? Now, if you can't understand that like 3 over 4, if you double that, you get 6 over 8, if that's hard for you to see, what you can do is something called cross multiply, right? Have you done this before? Cross multiply. If I take 8 times 3, what is that? 24. And if I take 6 times 4, that is 24. It checks out. So the sides are the same proportion, right? Like we've checked that. Sides are the same proportion, proportionate sides done. Now we have to check to see if the angles are congruent. Are the angles congruent? No, what are these angles right here when they have that little box?
90.
Those are all 90s. Are the other ones 90s? No, so the angles are not congruent, so these are not similar. Not similar. And then I'm going to say angles not congruent. The angles are not the same, so these are not similar figures. Does this make sense? Ish? Yeah? Something like that, right? Okay. Okay. All right. The last problem, We can use similar figures to like solve for things, right? Okay, so it's kind of hard to see on your diagram because your diagram is like a little darker-ish, whatever, but we're going to redraw him. So if you look at my diagram, you can see him maybe a little bit better. And what we're trying to do is we're trying to figure out the distance across Pine Lake, okay? Pine Lake is this guy right here. Do you see him? If I make him like yellow color, distance across Pine Lake. I want to know that distance, but the only way of knowing that distance is for me to actually like walk through the water, right? Okay? And I don't want to do that because I don't want to get wet, okay? So we're going to use similar triangles to figure out what that distance is, okay? So let's do this. I'm going to extend this out and I'm going to make this into a triangle, right? Do you see that big triangle? And let's draw him down here. So I have this guy. Just make this big triangle right there. There he is. And let's label some dimensions. Here's where my lake is. There he is. He kind of looks like a Santa hat on the side. But anyway. Okay? This is what we don't know. This is what we're trying to figure out, okay? But we do know this top side right here. Anybody want to take a stab at how long that top side of that triangle is? 220, Remington says. Do you know how you got that?
He added 120.
From here to here is 120, from here to here is 100, right? Does that make sense? Okay? And then we don't really care about this hypotenuse side. Like, we'll just leave him blank, right? Okay? Then we have another triangle going on there. I don't know if you can see him very well, but he is this little guy right here. Okay? That little guy. So we're going to draw him. And he looks, I don't know, something like this, right? But those two figures, one of them's bigger, one of them's smaller, those two are actually similar triangles. The small one inside of the big one, they're similar triangles. And let's label the sides of him that we know. So what do we know?
55.
We know 55 is this side right here, and we know that
The other side is 100.
this is 100, right? That top side is 100. Okay, now I can use that information to find the missing side, right? Like, let's call this guy X because we don't know what he is. And we can use a proportion and cross multiply and divide to figure out what that missing side is, okay? So let's do something over something equals something over something. What would you like to do?
220 over 100.
Okay, 220 over 100. So she wants to go right or left to right. 220 over 100 equals X over 55, okay? So we're going that direction. Now the reason why I drew arrows on this is that you can illegally set up a proportion. You can do illegal things in math a lot of times. And I don't like it when you do that. So don't do that. But here's what something illegal would look like, right? So Megan went 220 over 100, right? Left to right, 220 over 100. And let's say Remington said, okay, now let's go 55 over X. So we went first left to right, but now we're going right to left. We can't do that. That doesn't work. It will end up giving us not the correct answer. Another thing that I could do, I could go 220 over X, right? But then I would have to go 100 over 55, right? I could go top to bottom, or bottom to top, It doesn't matter, right? You can go a bunch of different directions as long as you do the same for the second proportion, right? Okay, and these are equal to each other, so don't do this one, okay? These are equal to each other. There's an equal sign here, right? But that allows me to cross multiply and divide. So if I multiply these together, that is 100x, and then I have to put equals, right? 100x equals, and then I have 220 times 55, which is like 121 with 2 zeros, I believe. Okay, makes sense? If I multiply those together. And then, to solve for x, I divide by 100, right? Okay, don't get your calculator out. X equals, if you take 121 with 2 zeros and divide by 100, you can just cross the zeros off. Did you know that? Yeah. Right? So x is 121. And what's the units on that? Meters, okay? And I have found the length across the river without having to walk into the water. Make sense? Using similar triangles. Good? Okay. That's all I have for you. 2 through 12, the evens out of that section. Make sure that you are on page, not page 21. I wrote that down wrong. Page P21, right? We're still in chapter 0. So page P21, if you go to page 21, you're on the wrong spot. Page P21, 2 through 12, the evens. There you go. Okay? You got lots of time. Holy cow, you have lots of time to work. Man, oh man. All right? If you get stuck on number 8, let me know. That's going to be the doozy. All right?